Hello and welcome to Noel's Retro Lab. Today we're going to be looking at a slightly unusual computer, one that many of you may not be familiar with, the Spectravideo SVI 728. It's actually a new computer for me as well. I've never used one and much less looked inside. So join me today as we learn together about this computer, we open it up, we see what's wrong with it, and hopefully fix it. So here's the SVI 728. It's actually an MSX computer, the MSX standard, along with its cartridge door in the back. So it has an expansion, what looks like an expansion port. And what's really good for us is that not only does it have the RF out, which it's nice, but also it looks like it has composite out right there. It also has the joystick ports. And then over here has an on-off button, always welcome in these kind of computers. A lot of them skip that. And a really unusual power connector for a very unusual power source. Look at that. The output of this is 16 AC and 9 volts AC. That's a very unusual power supply, which is one of the reasons why we have a second SVI 728 over here. So a friend of mine actually brought this and said, it's not working, there's something funky going on the screen, can you fix it for me? And I said, sure, I can have a look at it. And it just so happened that I had one in the lab, but I didn't have this weird power supply, so I never had a chance to test it. It was waiting until I was able to manufacture something that outputted this kind of voltages. So if everything goes well with this, we may have a look at this one and see if it works, and if not, we'll do a second repair on that one. But this one is the priority today. The first thing to do is to try it out and see what kind of output, if any, we get on the screen. So it's all plugged in, and let's see. Okay. All right. That's what my friend meant by garbage on the screen. So if oh, interesting. We hear the beep, and things move on the screen. So it almost looks like it's working. I expect to see the screen of an MSX, the basic interpreter screen of an MSX, and it kind of looks like that. The colors seem about right. There's just garbage on the screen. You can almost see the prompt, and as you press enter, things change on the screen. So what I'm guessing is that it's something to do with the video memory. The MSX computers have a separate system memory and video memory, unlike other computers like the Amstrad or the Spectrum that share the same memory but then need some mechanism to separate access to it. I would expect that if that video memory fails, the computer would work correctly but would just display this kind of garbage. So let's open it up, look for that video memory, and see if we can fix it up. Now we carefully lift the case. Careful, it's got to be a keyboard membrane somewhere. What is this? The keyboard membrane seems to be held with like hot glue to the board itself. I did a little research, and it turns out this is not something that someone added afterwards. Apparently they did this at the factory. They were cutting corners, and instead of adding a correct keyboard membrane connector, they just soldered it directly to the board and added some hot glue to protect it. And this isn't just for the keyboard membrane connected to the main board. They did this for everything. For the keyboard membrane to the keyboard itself, for the power board connected to the main board. Incredible. So just leaving the botched job of the hot glue aside, let's see what else we see on this board. On the very top, we have the CPU. It's just a standard Z80. Down in the bottom left, we have the ROM, and interestingly, there's 3 empty spots for ROM. I'm not really sure what the purpose of those are, whether users were supposed to add more to them or what. Down at the bottom, we have the system RAM. So it's 8 ICs of 64K bits each. So All 8 of them together make up for 64 kilobytes, which is the amount of system RAM this computer has. Then at the bottom right, we have the video RAM, those 2 chips. Each of them is 16K of 4 bits. So again, the 2 together make 16 kilobytes, which is the video RAM the Spectravideo 728 has. On the right, we have the video controller, the video chip. Then under the ribbon cable, we have a standard AY sound chip. And then at the very top, we have a PPI, or a programmable peripheral interface. Okay, so let's find out what's going on with the video RAM. So we already figured out that the video RAM are those 2 chips in there. The pinout is very similar to some of the other DRAM. So this is 4416, and the pinout is actually the same as the 4464 that is common in Spectrum and some of the later Amstrads, but those have 64K of 4 bits, whereas these are 16K, but the pinout is exactly the same. So most importantly, we want to be looking at the 4 input and output bits. So let's check out those pins. Let's turn it on. And now this one over here is one of the... Yeah, okay, so there's some activity there, and there's the second one, yeah. The 3rd bit in this one is there, and the 4th bit is this one, yep. And just to check, CAS is this one, 5, yeah, that looks good. So this one, bit 1, bit 1 is nothing. That's not good. Bit 2, okay. Bit 3, nothing. And bit 4, nothing. I mean, are we getting... Yeah, we are getting CAS, and we are getting the row address signal, and we are getting VCC. So this looks really pretty much dead, this one, which could correspond to the weirdness that we're seeing every time we read a value from video memory. We're probably getting 4 okay bits, which is why we're getting probably the color and some of the hints of empty versus character, but then we're always getting 4 bits of 0 somewhere in that word. Let's definitely replace this IC and see what happens. It turns out that removing the board is quite unpleasant when you have that keyboard membrane stuck in there. And it's not even just the keyboard membrane, it's that sideboard with the power and the video generation. It's also held together with that hot glue, which makes this quite difficult and unpleasant. I'm even gonna have to leave the keyboard hooked up while I'm desoldering that chip. That's the one. Let's stick out the big guns. I don't want to have to flip the board over again, and this one came out really nicely, so just a little bit with my hands, and there he goes, comes right out. Now let's put in a new socket and solder it in place. I had an extra memory IC from an Atari 800 XL, so there we go. Time to try it. I've connected everything. We haven't put it in the case yet because it's such a pain to put back in and out with this mess of glued cables everywhere. But everything is here, it's plugged in, so if we turn it on, I expect to see the MSX startup screen, assuming everything went well. So let's see it. And there we go. That looks perfect. Yep, there you go. So the only problem was that one chip from the video memory. All right, it's all back together. Although one thing I noticed is that the keys are not working very well. So the enter key works, but some of them, they seem to work. They seem not to work, but then I press hard and they do. It makes me think that it's not so much of a problem with the ribbon cable. So I'm wondering if this is just really dirty keyboard. I mean, it is really dirty, but it could be really dirty underneath. So let's open it up and let's give it a good scrub. Removing the keyboard is a pain still because we can't completely disconnect it. So it's just several screws around the edges, and we can just lift it like that. We don't really need to remove the keycaps for this, but might as well. They're all dirty anyway. Let's give them a good wash. Now we remove all those tiny little screws in the back and carefully lift the back piece without flipping over the keyboard, otherwise all those pieces would fall out. And there are the membranes. Ooh, they're kind of stuck. Do you hear that? Yep, we definitely need to give those a good cleaning. The membranes aren't particularly dirty, but I'll clean every contact with alcohol so it makes good contact when we push the keys. And now we just put them back on the keyboard and reassemble everything back together. We put all the tiny screws back. And now the actual keycaps once they've been nicely cleaned and dried. I couldn't leave the case in that state, could I? In the bathtub with it. Sometimes soap isn't good enough. You can see, leave some stains. It's particularly noticeable in these light cases like this one. So in cases like this, what I like to do is use some baking soda. Just apply it on the case and a little bit of water and scrub with a rag. And that does wonders and removes all that dirt and stains. Yeah, look at that. Much better. Time to put the keyboard back in the case. And there you go. Okay, so it's all reassembled. It's much, much nicer and much wider. Can't do anything about this, unfortunately. There's some corrosion in the metal plate. If somebody knows a good treatment for this, please let me know. I've had this happen in some other computers like the Atari 8-bit, the Atari 800 XL. There's a lot of similarities actually between this and the Atari XL. The keys, the Ks, the plating. Let's turn it on and see what happens. So it should be working still. Okay, good. But now let's see if the keyboard works with our thorough cleaning. So enter key is still good. And it looks like all the keys work. Perfect. So it really was just dirty contacts on the membrane rather than something broken. So this one, I think we can call it done. All right, here is our SVI 728 number 2, and wow, what a difference. If I manage to get this one working, I'll definitely have a lot of cleaning ahead of me, especially the case. It seems it's in pretty bad shape. Interestingly, this plate is fine, but unfortunately has some sort of melted area. Probably the cables react to the case and cause this mark. There's pretty much nothing that I can do about that. Sort of sanding it, and then you may end up being worse off than it was before. So anyway, first let's try it and see what happens. Okay, so it seems to be working. straight out of the box. So all it was missing was just the power supply. But wait, there is more. I decided to try the computer on my regular CRT because over there I have an LCD, which is great to have it in the workbench, but it doesn't give it doesn't give very good image. So I decided to give it a good test and try it here. So I go to turn it on and yeah, it works, but it's all gray. Now, I've seen that before in other computers. It's usually a clock used to generate the video signal that over time drifts, and then you end up losing colors from the video image. Okay, so all unscrewed, and let's see if this computer also has that horrible glue job holding everything. Oh yeah, it does. Yeah, it's the same as the other one. I definitely see several adjustable resistors in the video generating area, which is right here. And it's usually safe to tweak them a little bit. The drift is usually so little that by doing a minor adjustment, it usually fixes it. There's two different ones. I'll try them both. See if that works. So, touching VR2. Oh, it did something. There you go. That's it. It was that simple. And there we go. Give it a good bath and some scrubbing, just like the other one. And I'm not going to say it's as good as new, because it's not. It definitely has still some problems, but wow, so much better than it was before. The only thing this computer still doesn't have is a power supply. Fortunately, one of my friends makes this 3D printed power connector that fits straight into the power port of the SVI 728. So that's going to be very useful. Now all I have left to do is actually figure out how to make a power supply that outputs those AC voltages. I'm going to leave his email in the video description in case you want to contact him. I believe he's selling these as a kit, which could be very, very helpful for restoring this kind of computer. Just to check my assumptions, I looked in the service manual for VR2 and VR3, the variable resistors 2 and 3, that I was tweaking to get the color back. And yes, it turns out they are part of the video generating circuitry. In this particular case, they seem to bias the input signal up or down slightly, which then matches with the results we got. I know in this video I've ragged on the Spectravideo's quality, especially based on those cable connections. It really pales in comparison to some of the other MSX computers like Sony or Toshiba or even Philips. But I have to say that one area where they did an exceptional job is in the service manual. I've seen a lot of service manuals for different computers, and this one just stands head and shoulders above the rest. It's 320 pages full of lots of amazing details. Architectural organization, bit patterns for different ports, full circuit diagrams, flowcharts for resolving problems, oscilloscope traces at different points, and even the source code to their BIOS. I wish every computer had a system manual like this. And there you have it. We managed to successfully fix these two Spectravideo SVI 728 computers, and we gave them a good face wash along the way. We learned some interesting things while doing that, like how horribly put together they are with glue and how uncomfortable they are to work with. But there were some other interesting tidbits as well, so I hope you enjoyed the video. If so, please give it a thumbs up and subscribe to the channel. Until next video, see you then.